Morning children. Today we learn 12th standard physics chapter 9 ray optics and optical instruments. So what is ray optics? Optics means light and light related phenomenon branch of physics. Ray optics means we consider light as a ray. So it has a natural property called rectilinear propagation. It travels along a straight line. So if we consider light traveling along a straight line, and what are all the phenomena related to it, like reflection by mirrors, refraction by lenses and glass slabs, like that. And how we are using the mirrors and lenses and glass slabs like equipments in optical instruments. About that only we are going to study in this chapter. So ray optics, we are going to study about reflection. What is reflection? It's change in path of light when it falls on reflecting surface on the same side. If it is reflecting surface like plane mirror, light comes and it is reflected on the same side. It's not going on the other side. And you studied the basic laws of reflection. The angle between incident and normal is called angle of incidence. The angle between reflected light and normal is called angle of reflection. If angle of incidence is 10 degree I and angle of reflection is also 10 degree. If it is 40 degree, angle of reflection is also 40 degree. Then incident light, reflected light, normal, all lie in the same plane of blackboard. So two laws of reflection is studied for normal mirror. So now we are going to deal with spherical mirror. Spherical mirrors in this 12th standard physics. So what are spherical mirrors? The plane mirror, if it is like this, spherical mirror either curved like this or it is curved like this. Okay, if you consider any hollow sphere and whose inner surfaces are silver coated, you can say for this, and here you can say part of the mirror, the outer surface is silver coated. If you take like this, you can say it is part of the mirror. Name this as AB. Here also you can name it as AB. So AB is part of hollow sphere. And now I need not consider this part because we don't need this part. So what are two types of spherical mirrors? To understand that I have drawn this. One is convex mirror. What is convex mirror? What is convex mirror? It takes this part of this hollow sphere. On the right side, it is silver coated and the left side becomes reflecting surface. That is called convex mirror. It's a curved mirror, spherical mirror. Okay. If you take this, the inner depressed surface is capable of reflecting light and the outer surface, projected surface is coated. So it is concave mirror. Now, in this convex or concave mirror, depending upon the reflecting surface, if it is projected like this, convex mirror, if the reflecting surface is depressed like this, that is concave mirror. So on the basis of reflecting surface only, we say whether it is convex or concave. What are the terms related with this mirror? The first term is called pole. The letter is P. The center of the mirror is called pole of the mirror. Pole of the mirror. Center of curvature. Center of curvature of the mirror. Center of curvature of the mirror. It is denoted by the letter C. It is the center point of the hollow sphere on which mirror forms a part. The center of the sphere of which the mirror forms a part is called as center of curvature of mirror, whether it is convex mirror or concave mirror. Then, what is radius of curvature of the mirror? Radius of curvature of the mirror. The radius of the hollow sphere of which mirror forms a part is called radius of curvature of the mirror. So, P to C is called radius of curvature. It is denoted by R for convex mirror. If it is concave mirror, P to C, it is radius of this sphere of which concave mirror forms a part. So, this is radius of curvature. Then, what is principal axis? Principal, P-A-L, not P-L-E. Common mistake done by all students, P-L-E. So, P-L-E, principal axis. What is principal axis? Is the line passing through P and C of a mirror. It's a straight line passing through pole and center of curvature of the mirror. It's called principal axis. Here I want to make for concave mirror, the line passing through P and center of curvature is called as principal axis. Okay. Then, what do you mean by principal focus? Principal focus. Yep. You can say it's a point between P and C exactly in the middle of P and C. If you take this principal axis, it's a point between P and C. Let me first say for convex mirror, a narrow beam of parallel light diverged by concave mirror, and the diverged ray appears to come from focus. The diverged ray appear to come from focus. Appear to come means it is called visual focus. Actually not coming from focus. Lagta hai appear to come from focus. A narrow parallel beam of light falling on convex mirror after reflection appear to come from a particular point that is called principal focus. It's a point in between P and C, exactly in the middle point on the line joining P and C. Okay. Let us do what is principal focus in the case of concave mirror. If you take concave mirror, center of curvature, and here a middle point on the line joining P and C. A parallel incident ray to principal axis. After reflection, it's there parallel incident ray. After reflection on the concave mirror are actually converged at a particular point, that is called principal focus. So separately, if you draw for convex mirror, first let me draw for convex mirror the parallel incident ray to principal axis after reflection from the mirror appear to diverge from a particular point, that is called principal focus. As it appears, it is called visual principal focus. It is for convex mirror. For concave mirror, principal axis pole, the narrow beam of parallel incident ray after reflection from the concave mirror actually converging at a particular point on the principal axis, that is called real principal focus of concave mirror. So real focus for concave mirror, virtual focus for convex mirror. And just now I made what is focus point, center of curvature. The next term is focal length of convex mirror. The distance from P to focus, pole to focus, is called focal length of mirror. The same is for concave mirror. The same is for concave mirror, pole, center of curvature, focus, principal axis. Distance from pole to focus is called as focal length of concave mirror. What is called aperture? Next term is called aperture. Next term is called aperture. If it is mirror, it is concave mirror, convex mirror. B mirror. The line joining A and B is called aperture of the mirror. The line joining A and B is called aperture of the mirror. It is called linear aperture because it is straight line. Linear aperture. Linear aperture. If mirror is like this, aperture is small. It is small aperture, large aperture. So depending upon the size of the mirror and shape of the mirror, it is called parabolic mirror. It is spherical mirror. The spherical mirror aperture is large. Parabolic mirror aperture you can consider here smaller. So you studied different terms. Pole, the middle part of the mirror is called middle point, not part. Middle point of the mirror is called pole of the mirror. The center of the hollow sphere on which the mirror forms a part is called center of curvature. Pole to center of curvature distance is called radius of curvature. The line joining pole and center of curvature is called principal axis. Principal focus, the narrow beam of parallel incident light after reflection from the convex mirror appear to diverge from a particular point on the principal axis. That point is called as virtual focus of convex mirror. The narrow beam of parallel incident ray actually converge at a particular point on the principal axis. In the case of concave mirror, that is called as principal focus, real principal focus of concave mirror. And whether it is virtual focus point or real focus point, the distance of principal focus point from pole is called as focal length of the mirror. Focal length is denoted by the letter F. Pole is denoted by the letter P. Center of curvature is denoted by the letter C. A radius of curvature is denoted by R. Principal axis is a line. Principal focus is denoted by F. Focal length is denoted by small f. Aperture is nothing but the point A and B join. That line is called as aperture. Okay, now you learn the terms related with spherical mirror. Coming to the relationship between radius of curvature and focal length of the mirror. For understanding this, you must know the rules for formation of image through ray diagram. You must know. What are four rules? Four rules for formation of image. I'll show left side for concave mirror, right side for convex mirror. Four rules. The first rule, it is concave mirror, pole, center of curvature, focus, principal axis. If you take a parallel incident ray, it means the object is at infinite distance. This ray is parallel to principal axis. Incident at a particular point, name it as E on the concave mirror. After reflection, it will pass through focus. That is first rule. Actually passing through focus in the case of concave mirror, if it is convex mirror, pole, center of curvature, principal axis, virtual focus, object at infinite. So the ray parallel to principal axis falling on the convex mirror. The normal at this point should pass through C. This is normal, and it is reflected such that the reflected ray appears to come from focus. The reflected ray appears to come from focus. So it is called virtual focus for convex mirror. Actually passing through focus called real focus. So this is rule 1. Parallel ray actually passing through focus after reflection from the concave mirror. Ray parallel to principal axis after reflection from the convex mirror appear to come from principal focus. Rule 1. Okay. Now rule 2. Rule 2. What is rule 2? Again come to concave mirror, pole, center of curvature, principal axis. Ray, it is focus point in between exactly. If it is 10 cm, should be 5 cm. Ray incident at pole. Ray incident at pole. And at pole, the PC line itself is called normal line. Normal line at pole. So if it is 30° angle of incidence, and the reflected ray also makes 30° with the normal. So reflection angle is also 30°, incident angle is also 30°. Incident ray, reflected ray, normal, angle of incidence, angle of reflection, both are equal. This is rule 2. And for convex mirror, pole, C, exactly middle point, if you make it 20 cm, this is 10 cm. If you don't make it exactly middle point, it will go wrong. The ray incident from object at an angle with principal axis at this pole, because principal axis itself is called as normal line at pole. If angle of incidence is 30°, angle of reflection is also 30°. Angle I is equal to angle R. So the ray incident at an angle I at the pole is reflected such that the reflected ray is also making same angle with the normal at pole. So this is second rule. Light incident at pole, how reflected from the concave mirror and from convex mirror. Third rule, which is passing through focus. So take concave mirror as usual. First mention pole, and at 20 cm mention C. At 10 cm exactly from pole mention F. Draw the principal axis. Here from the object, I consider one point of the object, consider a ray of light passing through focus. After reflection from the concave mirror, it will go parallel to principal axis. Parallel to principal axis. Here, convex mirror, make first pole and 20 cm, and C means exactly 10 cm focus in between P and C. A ray actually not passing, it appears to pass through focus. It appears to pass through focus. Incident in such a way, it appears to pass through focus. After reflection from the convex mirror, will go parallel to principal axis in the same side. Because if you draw the normal, the line joining the point of incidence with C is called as normal line. So here also angle of incidence is equal to angle of reflection. So the laws of reflections are true for spherical mirrors also, as in the case of plane mirror. The ray actually passing through focus after reflection will go parallel to principal axis. In the case of concave mirror, the ray appear to pass through focus and incident on the mirror. After reflection, will take the line path parallel to principal axis in the case of convex mirror. What is the fourth rule? What is the fourth rule? Fourth rule. This is concave mirror, convex mirror. Make exactly pole at 20 cm center of curvature, exactly in the middle focus point. Pole, center of curvature, exactly middle point, focus. Principal axis. You have to draw this first. I am not extending this principal axis on the right side of concave mirror because here reflection is not possible. Here reason is there to mention on the right side. You will come to the reason point afterwards. Now, suppose one object is there. One object is there. Here, object, point object. The ray from the point object passing through C. At the point of incidence, the normal is also same line. So, it will reflect back along the normal only. It is called normal incidence. If a ray is passing through C and falling on the mirror, that incidence is called as normal incidence, for which angle of incidence 0 means angle of reflection is also 0. So, if it passes through C and falling on the mirror, it gets reflected on the same path. So, it goes in the same path in the reverse direction. Here, object here, you consider the ray of light appears to pass through C. It cannot pass through C because mirror is there. This will reflect in such a way it goes back along the same direction because the same line is called as normal line. So the light passing through normal line is called as normal light. That incident of light is called as normal incidence. Normal incidence of light, for which angle of incidence is 0. The angle between incident light and normal, both are same line. So I is 0 means the reflected light, it goes back in the same direction. So you can consider either, this is normal incidence, angle of incidence is 0, angle of reflection is also 0. But if you consider refraction, there one more point you will learn, but here it is reflection, so we are not going to one more point. So in these 4 rules, to form image after reflection by mirrors, you need at least 2 rules. At least 2 rules. All 4 rules are not compulsory. Which 2 rules are convenient for forming the image? You have to select those 2 rules that we will understand in next part. So you studied about 4 rules to form image with the help of ray diagrams. Okay, now what is radius of curvature and how it is related by with focal length of the mirror? Just multiply by 2. I told you if it is 10 centimeter, multiply by 2, radius of curvature is 20 centimeter. Radius of curvature is P to C distance, focal length is P to F distance. So P to C distance is 2 times P to F distance. That proof only we want to give it. For that you take for both mirrors. First let us take concave mirror. Let us take convex mirror. Pole, I told 20 centimeter if we consider from pole C, 10 centimeter middle from P if we consider principal focus. Pole, 20 centimeter if we consider center of curvature, from pole exactly middle 10 centimeter if we consider, that is principal focus. Now to derive this relation, radius of curvature is equal to 2f. I need a ray from point object is C and incident point is E, and here if you have to consider normal means radius of the sphere at this point. that will pass through C. This is normal. So this is angle of incidence. I name it as theta. And angle of reflection. You know the first rule. The parallel ray to principal axis after reflection from the mirror will pass through focus. So angle of reflection is also theta. If this is theta, this is theta. This angle is also alternate angle theta. Theta plus theta 2 theta. So this angle is 2 theta. I draw a normal line. So from E to principal axis, that is En. This N you can ignore because you should not get confused with this N and this N. The same way here, a ray, you can extend it. A ray parallel to principal axis from a point object appear to pass through focus first at this point, name it as E, and here you draw E with C, that is called normal line. E with C, E with C, that is called normal line, and it is reflected such that you join this. It appears to come from here. It appears to come from here. It appears to come from here. You should be careful while drawing. Scale is required to draw this. Scale is required to draw this. This is normal drawing E and C, and here it appears to come from here, means you have to draw a scale like this. This is reflected, and this is incident angle. This is reflected angle. If this is theta, it is theta. This is 2 theta. I just draw a normal line from E to the principal axis. So this is the ray diagram. You must understand how one parallel ray actually passing through focus. In this case, the parallel incident ray appear to come from focus after reflection. And now, you must assume this mirror is small aperture. Small aperture, it means this point to this point, if you draw a line, that is small. So mirror is of small aperture. So in both the cases, first I am going to make tan 2 theta, then tan theta. As mirror tan 2 theta, opposite side by adjacent side. So opposite side is En, adjacent side is NF. Here one advantage of mirror of small aperture means distance from N is equal to distance from P, because N and P are very close to each other. The point N and point P are very closely located points. So distance from N is also equal to distance from P, not in numerator, on the principal axis I am telling. So En is equal to Pf. Tan theta. What is tan theta? Tan theta is opposite side En by adjacent side NC. NC. Opposite side by adjacent side. As mirror is of small aperture, I can take it as En by PC. And that mirror is of small aperture, 2 theta angles are angle is small, theta angle is also small. So I can write it as 2 theta only and theta only. If 2 theta and theta are small angles, I can write them as tan 2 theta as 2 theta, tan theta as theta. Now I want to divide 2 theta and theta on the left side of these two equations. So right side by right side also I can divide Pf, and here it will go PC by En when you are dividing on the right side of these two. En gets cancelled, theta gets cancelled. So PC upon Pf, PC upon Pf. P to C distance already you know, radius of curvature, and P to F distance is already you know, focal length. And if these P, F and R are measured in the opposite direction from pole to that of incident direction, they are taken as negative. So minus PC R minus F is equal to 2. So it gives R is equal to 2F is the conclusion. If R is 20 centimeter, F is 10 centimeter. The same way, same derivation you can do here also. Tan 2 theta is equal to 2 theta, opposite side En by NF. So I can write tan 2 theta as 2 theta, which is equal to En by NF, which is also equal to En by PF. Distance from N is equal to distance from P. Then tan theta, I can write it as theta because it is mirror of small aperture. So theta value is very small. En opposite side by NC, which can be written as En by PC. The same way, same derivation. So when you divide left side by left side of equation 1 and 2, right side by right side, you get cancelled. You are getting the same thing, PC by PF. P to C in this case is plus R and P to F is plus F. So it is R by 2. So it gives conclusion R is equal to 2F. So this is the relationship between the radius of curvature and focal length of concave mirror, convex mirror. In both the cases, R is equal to 2F. If F is 10 centimeter, R will be 20 centimeter. If F is 20 centimeter, R will be 40 centimeter. You must apply this knowledge for solving numericals. So here, ray diagram, it should be clear. How to construct correct ray diagram. How to derive. And what is the final conclusion? R is equal to 2F. Thank you. We will continue with mirror formula in the next session.